Okay, number 10. On page 19. Okay, I'm gonna start on the left side here. All right, we're starting on the left side. Look at how that left side is set up. What do you think we have to? Factor. Binomial factoring, okay? So let's do this in terms of x, and then we can come back and involve tangent, right? Because that looks a little bit complicated. So I'm going to do an easier version of the left. So anytime I see that relationship there where it's squared, first power constant, or fourth second power constant, it's going to be a factory problem. So let's solve an easier problem. Okay. So maybe you guys are, do factoring differently, either star method or going through grouping methods. But we have to basically go through this process, right? A times C is negative 12. So we got to figure out what two numbers multiplies to be negative 12 and adds up to be 1.
4 and 3.
Okay. 4 and negative 3, right? So 4 and negative 3. So we know we have to break this x squared in terms of 4, because we know 4 minus 3 equals to 1, but we're going to break it up in those parts there. Okay, everybody good with that? Okay, so now grouping methods, go through factoring here. Look for GCF. Divide, factor GCF out. I'm really dividing by that GCF. So 4 divided by 4, x to the 4th divided by x squared. I'm left with x squared plus 1. 4x squared divided by 4 squared is 1. Second GCF is minus 3. Okay, divide both sides by negative 3 here. Negative 3 divided by negative 3 is 1. I'm left with x squared. Negative 3 divided by negative 3 is positive 1. And you know you're on the right track if you can get your parentheses to match. You can. So the shared expression is going to come out. And then the expression that's left out of the parentheses will get their own grouping. Yes, yeah, I could do the star method as well. So star method here multiplies to be negative 12, adds up to be 1. We know it's going to be 4 and negative 3. But there is an a value of 1, so I have to worry about that as well. So 4 divided by 4 is 1. So it's x to the 4th here, so I can't just do x and x. I got to do x squared and x squared. So x squared plus 1, because 4 over 4 is 1, and then negative 3 over 4. I don't want any fractions in my factor form. So either way that you factor, just make sure you can do that. Any questions? Now this is the simpler version of the expression, right? We can now replace x with what? Tangent, right? So we went through the factoring with something that's more familiar, but now we want to bring back the original variable, which is tangent. looks like we're pretty close, right? We got that 4 tangent squared x minus 3 matching up. What's tangent squared x plus 1 equal to? Secant squared, there we go. Nope, I move this over.
Sorry, questions are gonna be on the test.
The test is going to be front and back. I think a total of 6 to 8 questions. For the verifying, you'll have 6 verifying problems, but you get to choose 4 out of the 6. So just like the quiz where you can omit problems, but here you can omit 2. Yes,
No double angle problem.
there's gonna be double angle, but no half angle.
Are they all like verifying or is it?
They're all,
Okay.
yeah, they're pretty much all verified. No. So basically, imagine your quiz plus double angle. Okay, and factor, like trinomial factor. We didn't see that on the quiz. Yeah. Yes, sum and difference identity. Sorry, yeah, sum and difference identity, double angle. All the formulas will be given to you. All right, let's try number 11. As tomorrow, I'll have a morning help session at 7:15. So you can either join on Teams or you can be in the classroom with me. I'll go over the review, the test review worksheets 2 and 3. So you can choose to do those at home or you can wait to do those with me tomorrow. Okay. So does everybody have that packet that I gave yesterday? So I have the key attached, so hopefully that will be good practice for you guys. All right, so again, I'm going to start on the left side. I see something that I can do. Anything stand out about that left side here?
Did you do like secant squared times secant squared?
Rewrite this. Do the truth identity.
Or rewrite the tangent?
I'm thinking in terms of factoring here,
Oh.
because factoring allows us to get it down in terms of a squared here. So what does that look like to you?
They have the same.
Difference of squares, right? Difference of squares means I have 2 perfect squares with a minus in between. So typically we've done a squared minus b squared, right, which is a minus b times a plus b, but we can also apply this for a to the 4th minus b to the 4th. And it'll be what? A squared minus b squared, and then a squared plus b squared, right? So basically you branch your terms into perfect square roots, and then one is positive and the other is negative. So we can do that with my expression there. I can break secant to the 4th into secant squared, and tangent to the 4th, I can break down this tangent squared. So secant squared x minus tangent squared x, and then secant squared x plus tangent squared x. Okay, is there one expression that we can make disappear? So look at my identity here, secant squared minus tangent squared equals 1. So that's nice. I can just take this, make that a 1. That's just gonna basically disappear for us. I'm left with secant squared plus tangent squared. I want my answer in terms of 1 plus 2 tangent squared. So what can we look to change? Yeah. Yeah, so I can turn that secant squared into its identity, 1 plus tangent squared. Going to carry this tangent squared down as well. And then that becomes 1 plus 2 tangent squared x. Okay. Number 12. Okay, I'm gonna start on the left side. If you look, we probably don't want to convert this to be in terms of sine and cosine because the right side is already in the form that's given to us. So it's already kind of simplified already. But maybe we can make something out of nothing, right? So making something out of nothing means we do something, we multiply by something to create an identity that will allow us to kind of move forward in our problem. So we could either multiply the top and bottom by cotangents, right? That'll give us cotangent squared, which is nice. That'll give us something to work with. What's the other option?
Secant.
Secant.
Good, conjugate, right? And the nice thing about, I think both way could work, but I think multiplying by cosecant plus 1 may move us a little faster because there's a cosecant plus 1 that we're looking for, right? So if I can introduce that into the problem, then that will just naturally show up a lot faster. So, but again, you have multiple ways to get to your answer. I'm just trying to help us identify the fastest. So that cosecant of x a plus 1 is kind of giving me a hint. Okay, if I can just multiply by the conjugate, I should be able to. And conjugate has a nice way of turning into an identity for us. Okay, so I'll leave the numerator alone. I don't want to distribute that through, right? Because I'm already showing that cosecant a plus 1. I really want that denominator to turn into a different form for us. Okay. Okay. What does the bottom turn into here? Yeah, cosecant squared minus 1. Now, if I FOIL everything out, you're going to get the middle terms to drop out. So that's why there's only 2 terms left. And do we have an identity now to play with?
Oh, tangent.
Cosecant squared.
Yeah, cosecant squared minus 1 is equal to cotangent squared. Okay. Oops. Cotangent, there's 2 cotangents below, so I can take out one of them. Okay, so I should be able to match, and we should be done. Yeah. All right, page 20. We're just trying to simplify and trying to, this I guess is also kind of verifying. We're just having to match our answer choice there. Okay, what can we start with here? For number 1.
Secant squared.
Yeah, there's an identity that's showing up at the beginning here. Okay, secant squared over cosecant squared. What can I do to see the similarities between them? Yeah, everything up in terms of sine and cosine, right? Okay. Take the denominator, move it up, multiply by the conjugate. Oh, sorry, my bad. Reciprocal, my bad. The reciprocal of the denominator, right? And what does that turn into? Sine squared over cosine squared, the same thing as. Okay, number two, I see this is a co-function identity. Right? What does cosine of pi over 2 minus x turn into? Fine. Thank you. All right, what would you do next? Yeah, let's get the middle terms to match up a little better, right? Let's rewrite the tangent and cosine as sine. Sorry, rewrite that tangent as sine and cosine over cosine and see what happens from there. Right, what happens with the middle terms? Thank you. Middle term, things have to be sine x, so I get sine x minus sine x plus sine x. That's just sine x, right? Number three, look at how that's set up. We have to go through what? Factoring, okay? But factoring, typically, how do we like to arrange our terms from factoring?
See that, what's, so there's that in the beginning.
Yeah.
Constant at the end.
Yeah, that's right. So highest degree to lowest degree. That's typically the way that we like to see things. You can do it the other way, but it just looks less familiar. Okay, binomial factoring. Let's do an easier problem, more familiar problem. Okay, grouping method. Multiplies to be a times c. 1 times 1 is 1. Adds it to be -2. So what two numbers multiplies to be 1, adds it to be -2? -1 and -1. Okay, so that means I gotta change that middle term. That will add up to be -2. We said -1, -1. Four terms we can group. GCF for my first two. GCF is just a -1 there. Right, my parentheses will merge into just one thing, right? That's the common factor there. And then the terms left out of the parentheses will create their own group. Okay, but my variable is not really x, right? My variable is cosine. Oh, sorry, they're both -1 here. Okay, we have an identity, right? We have sine squared plus cosine squared x equals 1. So what would that look like if I were to rearrange my identity to make cosine squared x minus 1? Close negative sine squared, right? If I take my identity and rearrange it to make it look like cosine squared x minus 1, I got to move that 1 from the right to the left, but I got to move that sign from the left to the right. That sign will become negative. So I'm left with negative sine squared x times negative sine squared x, because they're both cosine squared x minus 1, right? And then if I multiply the two, negative sine squared x, what do I get? Sine 40. Yeah. Let's see. Okay, we may not get through everything, but skip number 7. We're not gonna do any half angle identities, okay? But try number 6. Okay, I think 4 is pretty straightforward. You've seen that on the quiz. Number 5 is a little bit of difference of squares up top, and it cleans up nicely. Number 6, you're gonna have to use your even odd function identity. Look at your formula sheet, see if you can rewrite those terms. Okay, what can I do with that cosine negative x? What can I do with secant negative x? What can I do with tangent negative x? Minus, yeah, I can pull that negative. Okay, look at my left side, look at my right side. I'm trying to get to 1 plus sine x. So how would you move forward with? Yeah, let's get it. We got to get that sine and cosine to show up, but we know we got to do common denominator in the denominator or in that in this complex fraction, and then we can begin to, yeah, then we can move it up. Oh, that's nice. I already have a common denominator in that fraction. Okay, numerator, divide my denominator, same thing as multiplying the denominator by its reciprocal. Okay, we're not quite there yet. I have cosine squared over 1 minus sine x. At least I've gotten it down to one fraction. What can we do next? Yeah, rewrite that cosine squared. Okay, getting closer. I can do something with this numerator here. What can I do?
1 minus sine.
Yep, difference of squares, right? A squared minus b squared can be factored into a minus b times a plus b.
cancel out the square with that sign. That would-
Oh, wait.
Plus. It's the same thing, it's just,
Say it again?
I got rid of the sign in the denominator and then the sign is squared, it's just sign times sign.
Oh, you,
Unless it's just not a correct step. I got-
Yeah. but how did you get that plus? Oh, you divide it.
Divided by-
We can't do that. Yeah. Remember, you cannot cancel across addition and subtraction. As tempting as it is, it's not the same thing. Yeah. All right, let's go to page 21. I think 8 is pretty easy. Let's skip that one. Okay, let's do 9. 9 is not too bad, but we want to see if you guys can identify that first step. It's always that first step, right? When you get that first step down, then everything kind of falls into place. Okay, so take a look at that left side. Anything stand out that we can do? Oh, sorry about that. Thanks. Yeah, so recognizing that near, I think that's something that that I saw on the quiz that I see some students have trouble identifying is looking for that GCF, right? You can get away with doing something else other than GCF, but it just takes a lot longer. You know, if you can find that GCF, a lot of times it'll kind of move you through the problem a lot faster. So tangent cubed x, tangent x, these are both, they both share a tangent x. I can factor a tangent x from the numerator. So what that means is I'm dividing a tangent x from both tangent cubed and tangent x. So tangent cubed x divided by tangent x is just what? Tangent squared x, yeah. Okay, and then tangent x divided by tangent x is 1, so plus 1. So being able to take that GCF out, you're able to see that identity show up for us. That's very nice and clean. Okay, so what's next?
Secant squared x.
Tangent squared of x plus 1 is secant squared x. Okay. Okay, and then are we almost there? Yeah. There's our answer, tangent x. Yep, cancel out. Yep. Number 10. Let's just talk about the first step here. What's the first step?
Cosecant times 1.
Like cotangent or.
Yeah, I think if you multiply by cotangent or cosecant of x minus 1, you'll be fine. Yeah, so I'll do cotangent of x, but cosecant x will work as well. Yeah, you'll get identity to show up. The denominator can be turned in terms of cosecant. Difference of squares, reduce. Okay. Cotangent squared x can be rewritten as
Cosecant.
difference of squares.
Also multiply by cosecant.
Yeah, you can also multiply by cosecant of x minus 1, and you'll get the same process. You'll, very similar. You'll get the identity show up in the numerator, and then you can go from there. Okay, number 11. What's the most efficient first step here? Yeah, that GCF. So I think I saw this as a problem that students, some students got the right answer without GCF, but it just takes a lot longer. If you can look for something common between the two and take out that GCF, it'll make the really, really quick problem. So taking out a cotangent x means that I'm dividing that GCF out. Whatever's left over will go inside the parentheses. So if I divide this by cotangent x, I'm just left with secant squared x minus 1. Sorry, secant squared x, and then the cotangent divided by cotangent is 1, so minus 1. What's secant squared minus 1? Tangent squared. I want my answer in terms of tangent, so I'll just convert this cotangent. Take out one of the tangents, I'm only left with a tangent up top. Okay, I think 12 is easy. Just FOIL everything out, combine like terms, and eventually it'll turn into 2 sine x cosine x, which you can use double angle to get it back in terms of sine 2x. 13, convert everything in terms of sine and cosine. Oh, actually, yeah, let's do 13 here. We want to make sure we can still do these problems. So 13, let's start on the left side here. First step, get that cotangent in terms of sine and cosine. What's next? Yeah, cosine squared can be rewritten as
1 minus 1.
that is a factoring that we can do, but it won't move us closer to where we want to be. Now, good. This is one fraction, right? You're left with 2 terms. So that's something that is helpful to be able to recognize, right? If I have one fraction, but I'm trying to get to 2 terms, I can always separate into 2 fractions, and that can help me move to my next step. Right? So 2 fractions. I have 1 over sine b minus sine squared over sine. 1 over sine b is the same thing as cosecant. Sine squared over sine is just sine. Okay, let's go to our review 2. Let me pick out some problems here. I want to do a sum. I want to do a sum and difference one. We haven't done that for a while here. Let me pick something out from the packet. Sorry. Thank you. Actually, let's do a double angle identity here. This is worksheet 2, number 5. So number 5, I'm going to choose to start on the right side here. It's easier to start some with more complex to try to simplify it. Okay, so what would you do first here?
There was 2 squares.
Mm.
You probably top one.
Yeah, double angle identity, but if you look at cosine 2x, right? Cosine 2x can be expanded into which 3 options? Everything's in terms of what?
Cosine.
Sine or cosine, right? So why don't we just get sine and cosine to start showing up and go from that perspective? I mean, this difference in squares, but we're not going to get very far with that, right? Oh, I got 2 sets of common denominator I got to work through here. My common denominator for the top is cosine squared. Okay, balance the fraction. The first fraction is missing the cosine squared, so I need to balance the top with the cosine squared. Second one looks fine. The denominator also has a cosine squared axis. Everything is under 1 fraction now. Multiply by the reciprocal. Now, what's cosine squared plus sine squared? Just 1, right? So I can just put divided by 1 here. Okay, what goes away? Cosine squared. And what's cosine squared minus sine squared equal to? Yeah, that's a double angle identity, right? Cosine squared minus sine squared is cosine cubed x.
If you made 1 plus tangent x into
Secant squared.
secant squared, first squared, yeah. Wouldn't it, like,
Oh yeah, that could work too, right? Then you'll get 1 over secant squared x, which is cosine squared, minus tangent squared over secant squared.
You would still have
Which
to
is-
use
Yeah, yeah. But that works too, yeah. Okay. Any questions about tomorrow? Yeah.
Plus square x, sine square x.
Okay, yeah. So once I get that cosine squared x minus sine squared x, I look at my summary sheet. And cosine squared minus sine squared is equal to cosine of 2x. So I've reached my goal. Yeah. Okay, so I'll encourage you guys to work through as much as the review as possible as a way of practicing for tomorrow. Look over your quiz as well. If you missed any of your quiz problems, work through those again. Make sure you can do them. And yeah, I'll send out a reminder this afternoon, 7:15 tomorrow morning. I'll send out a Teams link if you want to join from home. Okay. All right, come get your phones.
I'm aware.
My identity's problem, one or the other.
The others are gonna be like,
Simplifying.
yeah. It's gonna be like this. Yeah, like this, where you gotta match.
I don't.
So
Okay.
it's like fine.
These are the people, ego, thing, but, I sent that email this morning, I don't remember. I input it here for. This 7 days. Okay, 5 months. Days. I'll be in class like 7. Post all the videos and stuff in Teams, right? Because then I can just watch them.
Yeah, so on my website.
I would watch
Yeah,
them.
yeah. So, yeah, I will continue to upload everything. I will upload the new. Let's see, when are you leaving? You're leaving?
Next Friday around 1, so I should still be here for
Right.
this class.
Okay, yeah. So you'll,
So I get back to work.
yeah, you'll have the new packet already. And I'll post everything on my website. And even if I don't, I have all the videos from last year, so even if I don't upload it, but then,
There'll be some-
yeah.
They're not just coming for like house.
Yeah, okay, sounds good, thanks.
Alright, so we don't have to know co-function, even odd or half-inch, right?
No, we don't know that, we do have to, we gotta do code function and even odd. We saw these on our review today.
They're on the test.
Yeah, they're on the test.
Alright.
Mhm.
So I'll go over to this. Where's the review?
Oh,
Adrian and I were worried, we told them we didn't put it on, I did a show on the speakers, and to do it information in remote. They have it in private, they went to Wisconsin. Yeah, I mean, people want to. I'm sharing it.